Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to solve system of equations that have 3 variables in them. So I do want to say I'm going to be solving this using what I call the elimination method, or sometimes the terminator method. But yeah, let's just get right into the video. So for the first problem I have, these are the 3 system of equations, and I want a solution for all 3, x, y, and z. So I'm assuming you already know how to use the elimination method for just a normal system of equations with 2 variables. If you don't know that, then seriously stop watching this video, learn how to do that because it's extremely important. So basically what I'm going to do is I'm going to choose a variable such as x, and then I'm going to choose an equation such as the top one, and my goal is to eliminate x with the other 2 equations. Now I didn't have to choose x, but the reason why I did choose the top one specifically is because, as you're going to see in a minute, I'm going to multiply the red boxed equation by -2 to eliminate the x here, and then I'm going to multiply it by +3 to eliminate the x in the third equation. And I'm going to try and keep it color-coded so you can see what I'm doing. So first I'm saying multiply the top equation by 2, everything by 2. Actually -2, because remember, I need to cancel out the +2. So that's going to get me -2x minus 2y plus 6z equals -24. And then I'm just going to rewrite the second equation, 2x minus 4y plus z equals -9. Now, just like in elimination method normally, I'm going to add the equations together. The x's cancel. I get -6y and plus 7z equals -33. Now I'm going to do the same thing. I'm going to multiply something by the red equation to cancel out the third equation with the -3. By the way, one thing you'll notice is these problems will take up like a full page of paper. So I'm multiplying this one by 3, giving me 3x plus 3y minus 9z equals 36. And then right below that, I'm just going to rewrite the third equation, -3x plus 2y plus z equals -2. And then I'm going to add these together. So once again, the x's cancel. I get 5y minus 8z equals 34. And now putting my 2 results I just got side by side, it will look like this. And now I have to ask myself, which variable would I like to eliminate next? This one doesn't really have a nice answer for me. I guess I'll try and eliminate the y's. And so to do that, I'm multiplying this one by 5 and the bottom one by 6. So for the first one, it's going to be -30y plus 35z equals 5 times -33 is -165. And then for the second one, it's going to be +30y minus 48z equals 6 times 34 is 180 plus 24, so 204. So then adding these 2 equations together, I'll get -13z equals, I think that's 39? Yep. And so then finally I just divide both sides by -13, and luckily this works out. I get -3 as an answer, and whenever you get a normal number as an answer, that's usually a good sign we did the right thing. Of course, the answer could be fractions, so if I did get a weird fraction as my answer, I'd probably double check my work one time just to make sure I didn't make any mistakes. But anyways, now that I have z equals -3, now I'm just going to work backwards. I'm going to choose one of these 2 equations. I guess I'll choose the bottom one. I'm going to plug in z equals -3 right here, and I'm going to solve for y. So then again, I'm saying I'm plugging in -3 for z. That's going to be 5y plus 24 equals 34. Subtract 24 from both sides, so that 5y equals 10, and then divide by 5, looks like y equals 2. And then finally, to solve for x, I have y equals 2, z equals -3. I just have to plug it in to one of the original 3 equations, which the first one will definitely be the easiest. So it's going to be x plus 2 minus 3 times -3 equals 12. X plus 2 plus 9 equals 12. 2 plus 9 is 11. and just subtracting 11, I'll get x equals 1. So there's two ways I can write my final answer. One is just putting all three answers next to each other, like this. Or the other way I can do it, I can write it as an ordered triple, like this. And either one of these are correct. I guess it depends whatever your teacher or professor prefers. So now that you know how to do it, let's see if you can get this next one on your own. So here's the next one. I do want you to try this one on your own, but before you do, I just want to give a couple hints. The first hint I want to say is a couple of these equations are missing stuff. Like for instance, the first one's missing z, the third one's missing y. So my recommendation to you, whenever that happens, just fill in like a plus 0z for the first one and a plus 0y for the second one. And then you still have to choose a variable you want to cancel out first. I'll leave that up to you. So go ahead, try it on your own now, and when you're ready to see the solution, unpause the video. Okay, so I'm going to try canceling out y, since y is already gone in the third equation, and all I need to do is multiply this second equation by 2 to cancel it out with the first one. So multiplying the second equation by 2, that's going to get me negative 4x minus 2y plus 10z equals 44, and then I'm just going to write the first equation right below that with the 0z right there. So this is nice. I got a 2 for 1 here because the 4x and the 2y both canceled out, and it looks like I have 10z equals 60. Now one thing I want to mention, this one actually has a shortcut. I don't have to do the same thing I did for the last problem, because right here I can just divide by 10 and I get z equals 6, and I'm already well on my way to answering the question. So then I go back to the original question, and now that I have z equals 6, I wonder which one I'm going to plug into next to solve. And technically you can do any one of these, but the best answer choice is definitely the third one, because negative x plus 2z equals 8, where I already know z is 6. This is going to be very easy. I can solve for x immediately. So subtracting 12 from both sides gets me negative 4. Divide both sides by negative 1. Looks like x equals positive 4. And now that I have both x and z, to find y, I just have to plug it into basically any of the three equations. I mean, I can't do the third one because it doesn't have y in it. So let's just do the first one. 4x plus 2y equals 16. We know x is 4 plus 2y equals 16. 4 times 4 is 16. Subtract 16 from both sides. 2y equals 0. Divide by 2. 0 divided by 2 is still 0. So then my final answer is x equals 4, y equals 0, z equals 6, or as an ordered triple, 4, 0, 6. And either one of these would be considered correct. So that's going to do it for today's video. Thank you all for watching. If you have any questions, please post them in the comments below. And I'll see you in the next video. Take care and bye-bye.